Yes, dear students, welcome back to my video lecture 8 on hydrogen and its compounds. So, in my previous video, we spoke about the different chemical properties of water, isn't it? I have compared the volume of water with volume of ice, and also I have told you that the density of water is maximum at 4 degrees centigrade, and then we spoke about its amphoteric nature, oxidizing and reducing nature, and what else did we speak about? Its hydrolysis nature, and also we very importantly I told you about the different types of hydrated salts, correct? So now in this video, a very important video for your NEET examination. So in this video we will be talking about hardness of water. We will be talking about what? Hardness of water. Yes, yes, hardness of water. Hardness of water. Yes. So now we know that water is of two types, isn't it? Water is of two types. What are the two types of water? It is hard water and soft water, correct? Yes, hard water and soft water. What is hard water? The water which do not produce yes, foam or lather or froth. Yes, water which do not produce foam or lather or froth with soap. It is called as what? Hard water, isn't it? Whereas water which produces yes, foam or lather, yes, or what? Froth with the soap, not with the detergent, with soap, it is called as soft water. Now what is the reason due to which the water becomes hard? That means, what is the reason for hardness? What are the reasons for hardness? Yes, let us talk about all these things. You have learnt it in your lower classes. I don't have to repeat it again and again. Now I am talking about the reasons for hardness. Reasons for hardness. Why the water becomes hard? Yes, why water becomes hard? So here the hardness of water is due to soluble salts of calcium and magnesium, isn't it? Yeah, don't worry about the other salts, don't worry about the other ions present in it. It is due to the hardness of water is due to what? Soluble salts of calcium and magnesium. For example, calcium bicarbonate, magnesium bicarbonate, calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. So it is because of the presence of these soluble salts, because of the presence of these soluble salts, water becomes hard. Water becomes hard. Well, hard water is of two types. Hard water is of two types. What are those two types of hard water? Yes, hard water is of two types. The two types of hard water are, I hope you know this, it is temporary hard water and permanent hard water. Temporary hard water and permanent hard water. What is temporary hard water? Yes, temporary hard water is due to the presence of soluble bicarbonates, that is, okay, yeah, HCO3 minus, okay, it is due to the presence of soluble bicarbonates of what? Calcium and magnesium, isn't it? That is nothing but calcium, okay, hydrogen carbonate or calcium bicarbonate, and magnesium bicarbonate, HCO3 twice. So if there is this salt, okay, if there is a, okay, if this salt is dissolved in water, then that salt is going to be called as what? Temporary hard water. Okay, what is permanent hard water? Okay, the permanent hard water, permanent hardness is due to the presence of soluble chlorides and sulfates, okay, chlorides and sulfates of calcium and magnesium, okay, calcium and magnesium, that is nothing but calcium chloride, yes, magnesium chloride, okay, yeah, calcium sulfate and what? Magnesium sulfate, isn't it? Okay, so this is temporary hard water and that is permanent hard water. Okay, now let us understand why hard water does not produce foam with soap. Yes, okay, why hard water, okay, yes, we are talking about why hard water do not produce, okay, yes, foam with soap, okay. Let us see what soap is. Okay, look here, soap is sodium or potassium salts of long chain fatty acids. Soap is sodium or potassium salt of long chain fatty acid. The composition, we will talk about soap in 12th standard, more about, okay, soaps in 12th standard, but try to understand certain concepts, that's it, not more, no, it is more than enough. Okay, so what is the composition of soap? It is C17H35COO minus Na. Look at here, it's a sodium salt of long chain fatty acids. How many carbon atoms are there? 17 carbon atoms. It's a long chain, understood? Okay, yes, it's a long chain, okay, it's a salt of sodium salt or potassium salt of long chain fatty acids. See, in this soap, okay, in this soap, see, this part is polar and hydrophilic, okay, are you getting my point? That means it will be attracted towards water. This part will be attracted towards water, whereas this part is non-polar, okay, okay, and it is hydrophobic in nature, that means it will not be attracted by water. Are you getting my point? So this region is called as polar part and it will be hydrophilic in nature. This hydrocarbon part is non-polar and it is hydrophobic in nature. Now when soap comes in contact with water molecule, look at what is going to happen. See, if this is the water molecule, now when soap comes in contact with the water molecule, the polar part will be attracted towards water, isn't it? Okay, yes, and all the soap molecules will get accumulated to form a large molecule, okay, and this large molecule we call it as what? This large molecule we call it as, okay, micelles, isn't it? Okay, these micelles are nothing but foam, okay, these micelles are nothing but what? Foam, okay. So when soap molecules comes in contact with water, the polar part gets attracted towards water, okay, they start to aggregate and form a large molecule, and this large molecule is called as what? Micelle, okay. But okay, if the insoluble salts of calcium and magnesium are present in water, what will happen? Okay, if there is calcium salt, okay, or magnesium salt, okay, is present in this water, that means if the water is a hard water, what will happen? See, instead, okay, so here, if the water is a hard water, that means this water consists of calcium ions and magnesium ions. Now in this case, what is going to happen? The soap molecules okay, the soap particles, instead of going towards water, they'll move towards calcium ions, okay, and they will form the salts of calcium. Okay, they'll form salts of calcium. That means they do not form micelles. Okay, hence there will be no formation of soap. Are you all able to understand my point? Okay, so if there is calcium ion or magnesium ion dissolved in water, now the soap particles, instead of going towards water molecule, they will go towards calcium ions or magnesium ion. They form salts with, they form, okay, what, insoluble salts with calcium and magnesium ion. Hence there is no formation of micelles. That means there is no formation of foam. That is why hard water does not produce foam with soap. Okay, so let us represent it in the form of a reaction now. Okay, let us write it in the form of a reaction. Let us say that the water is hard. That means it contains, if suppose water contains calcium chloride. Okay, this is from hard water. Now, okay, to this hard water we have added soap. Okay, what is soap? C17H35 COO minus Na plus, isn't it? Okay, now, okay, what will happen? So here this part, that is the polar part, okay, this part combines with calcium to form a salt. What salt? Insoluble salt, C17H35 COO twice plus 2 molecules of NaCl. This gets precipitated. Okay, this is called as scum. What is this called as? Scum. Okay, so when soap is added to water, it gives a precipitate. Okay, and what is that precipitate called as? Scum. Okay, instead of forming foam, it gives rise to a precipitate. That precipitate is nothing but scum. What is scum here? It is nothing but insoluble salt of calcium. Okay, insoluble salt of calcium. So since there is formation of precipitate, there is no formation of foam. That is why we say that hard water does not give foam with, okay, soap. Understood? Now, how to convert hard water into soft water? How to convert hard water into soft water? That means methods of removal of hardness. Methods of removal of hardness. What are the different methods of removal of hardness? Okay, yes, let us understand this. Methods of removal of hardness. Okay, what do you mean by, okay, converting hard water into soft water? What does hard water consist of? What does hard water consist of? Hard water consists of what? Calcium, okay, insoluble salts of calcium and magnesium. See, if by any case, if by any chance, if I can remove this calcium ions and magnesium ions in this water, then that water will be free from, okay, calcium ions and magnesium ions. Hence, this is going to be called as what? Soft water. Okay, this is going to be called as soft water. So my aim is to remove the calcium ions and the magnesium ions present in the water, so that the water becomes free from all the soluble salts of calcium and magnesium. Hence, okay, the water will be converted as what? Soft water. So what are the different methods of, okay, converting a hard water into soft water? What are the different methods? So we have two methods. Okay, as I said, we have got okay, two different types of hard water. See, for temporary hard water, okay, yes, we have got two methods. Okay, that is called as, one is by boiling. The other one is called as Clark's method. Okay, I told you what is temporary hard water. If the water contains the bicarbonates of calcium and magnesium, the bicarbonates of what? Calcium and magnesium, then that water is called as what? Okay, temporary hard water. Now, okay, now heat this water, boil this water. What happens upon boiling? Okay, see, this is soluble salt, isn't it? Soluble salt. Okay, this is soluble salt. That means it is dissolved in water. Okay, that is why water is behaving as hard water. It is not giving foam with what? Soap, isn't it? Now, when I heat this hard water, what will happen? This calcium bicarbonate, okay, will decompose to give what and what? Calcium carbonate carbon dioxide and water. Okay, look at here, it is giving rise to an insoluble salt. Okay, it is giving rise to what? Insoluble salt. That means it is forming a precipitate. It will form a precipitate of what? Calcium carbonate. Calcium carbonate is insoluble in water. So when bicarbonate, calcium bicarbonate is heated, it decomposes to give what? Calcium carbonate, carbon dioxide and water. Calcium carbonate is insoluble in water. It gets precipitated. Therefore, this can be removed by simple filtration. Okay, it can be removed by what? Simple filtration. Hence the water will become free from calcium ions, isn't it? Now what happens if I heat this, okay, water containing magnesium bicarbonate? See, this gets precipitated to give what and what? Magnesium hydroxide. It is also insoluble precipitate. It is insoluble in water. Magnesium hydroxide is insoluble in water and it gives rise to carbon dioxide. 2 molecules of carbon dioxide. Understood? Okay, look here. Initially it was soluble in water. Now when I have heated this, it is forming a precipitate because magnesium hydroxide is insoluble in water. Again, this precipitate can be removed by what? Filtration. Therefore, the water becomes free from calcium salts and magnesium salt. Hence, it becomes a soft water. This is one simple method to convert a temporary hard water into soft water. Now, what is this Clark's method? Okay, what do you mean by Clark's method? So, Clark's method is nothing but Clark's method is nothing but here what is that we're going to do is we will add calculated amount of lime. We will add calculated amount of lime. Calculated amount of lime. Lime means what? Calcium hydroxide. So to this hard water, we will add calculated amount of lime. Okay, when I add calculated amount of lime, CaOH twice, okay, isn't it? What will happen? Again, it gives rise to what? Same phenomena takes place. It will give rise to insoluble salts of calcium and insoluble salt of what? Come on, okay, magnesium, insoluble salt of calcium and magnesium. Are you getting my point? Yes, 2 molecules of CaCO3 and 2H2O. This becomes insoluble. We get a precipitate, and this precipitate can be removed by what? Filtration. This is also precipitate. This is also precipitate, and it can be removed by what? Okay. Yes, it can be removed by these precipitates can be removed by filtration. So again, water becomes free from the salts of calcium and magnesium. Okay, and it becomes what? Soft water. So in Clark's method, we will just boil. Okay, or else we will treat this hard water with calculated amount of lime, wherein it forms insoluble salts of calcium and magnesium. Which are those insoluble salts of calcium and magnesium? That is calcium carbonate and magnesium hydroxide, and those insoluble salts can be removed by filtration. Okay, this is how we convert temporary hard water into soft water. Okay, how about converting a permanent hard water into soft water? Okay, how to convert a permanent hard water into soft water? Okay, there are 4 methods now. Okay, to convert a permanent hard water into soft water. Yes, we have got 4 methods. What is that? First one, by treating it with washing soda. Okay, by treating the hard water with washing soda. What do you mean by washing soda? It is sodium carbonate, isn't it? Okay, by treating the hard water with washing soda. Next, we have something called as Calgon's method. Okay, yes. Next, permuted process. Permuted process. Okay, and lastly, ion exchange resin method. Ion exchange resin method. ion exchange resin method. So we have got 4 methods to convert a permanent hard water into soft water. Let us discuss one by one. So now first one, okay, what happens when I add, okay, what happens when I add, okay, so washing soda to permanent hard water. So what do you mean by permanent hard water? I have already told you. If the, okay, water contains chlorides and sulfates of calcium and magnesium, okay, water contains chlorides and sulfates of calcium and magnesium, then that water is called as permanent hard water. Now to this permanent hard water, okay, I'm going to consider this or this, okay, anything is fine, because the same thing will happen with everything. Okay, so now if I treat this with, okay, washing soda, that is going to be nothing but, okay, sodium carbonate, the same phenomena will take place. Okay, it will give rise to 2 molecules of sodium chloride. What is happening? This is soluble salt. This was soluble salt. Upon treating the soluble salt with sodium carbonate, okay, so it is forming an insoluble salt. It is forming what? Insoluble salt, isn't it? It will give rise to an insoluble salt, and this insoluble salt can be removed by simple filtration. That's it. Okay, understood? A very simple method. Okay, that is by adding what? Washing soda. Next one, okay, something called as Calgon's method. Calgon's method. Okay, how about Calgon's method? Calgon is not the name of the scientist, it is the name of a chemical. Okay, what is Calgon? Okay, Calgon, look at the formula for Calgon. It is NaPO3 6 times. NaPO3 6 times. Actually, it is the exact formula is Na4 Na2, okay, PO3 6 times. Na4 Na2 PO3 6 times. This compound is called as Calgon. The commercial name of that compound is Calgon, and the name of this compound is sodium hexametaphosphate. Okay, sodium hexametaphosphate. Are you getting my point? Now let us treat, okay, yes, let us treat hard water with this Calgon. Okay, what is going to happen? Yes, okay, look here. Yes, CaCl2, okay, is treated with Calgon. What is it? Na4, okay, Na2, okay, PO3 6 times. Now, okay, there will be exchange of, okay, ions. There will be exchange of ions between the hard water and this Calgon. Okay, what is the exchange of ions? See, okay, 1 calcium ion will be exchanged for 2 sodium ions. 1, okay, calcium ion will be exchanged for 2 what? 2 sodium ions. Therefore, it is going to form a compound like this. Okay, 2 molecules of Na, 2 Na plus Cl2 will form NaCl, and what is the molecule formed here? It forms, see this, Na4. Okay, I told you 2 sodium ions are replaced by 1 calcium ion, so this is going to form CaPO3 6 times plus, okay, 2 NaCl. Now look here, okay, now earlier the calcium ion was in water, but after the, okay, formation of complex here, what is happening? Okay, calcium is no more, okay, available inside water. It is busy in forming the complex with phosphate, isn't it? It is busy in forming the complex with phosphate. It is not available freely in water. Therefore, water becomes free from what? Calcium ion. Water becomes free from calcium ion. Hence, okay, hard water becomes what? Soft water. Hard water will become soft water. Okay, so yes, the calcium ions of hard water, okay, yes, will replace the sodium ions of this Calgon, okay, to form this complex. Now calcium ion is no more available freely in the hard water. It is busy in forming complex with phosphite. Okay, hence, okay, hard water becomes what? Soft water. And what is this process called as? The process is called as, the method is called as Calgon's method. Calgon's method. Now, what do you mean by permuted process? The next method, permuted process. Okay, yes, what is permuted process? Okay, by the way, permuted process, or it is also called as zeolite. Permuted or zeolite. Okay, what are zeolites? what are zeolites? Okay, zeolites are okay, aluminosilicates. Zeolites are aluminosilicates. Aluminosilicates. Are you able to understand? Look at the formula for permutate. It is Na2, okay, Al2, Si2O8. Okay, this molecule is called as permutate or zeolite. Okay, so can I write this? Okay, can I represent this as Z? I'll represent this Al2 Si2O8 as Z. Therefore the formula gets reduced to what? Na2Z. Okay, what is Z here? Z is Al2 Si2O8. Okay, so I'll use this. Okay, instead of this writing the full formula, I'll use this formula. Okay, yes. So what are zeolites? Zeolites are aluminosilicates. And what are the formula for permutate? It is Na2 Al2 Si2O8. Al2 Si2O8. I have reduced this as what? I've taken this as Z. Therefore now the formula will be simple. It is Na2Z. Actually, what are permutates? Look here. See, permutates. See, they are, okay, organic compounds. Okay, they are the compounds. They are the compounds. Okay, with definite pore size. Definite pore size. Okay, that means, see, if this is a permutate, so on the surface of this permutate there will be pores. Okay, there will be what? Pores. Understood? Okay, yes, on the surface of this permutate there will be pores. That is why I'm telling you, okay, these are the compounds with definite pore size. Definite pore size. Now what I'm going to do, I'm going to run the hard water. Okay, what type of hard water? Okay, permanent hard water which contains calcium, chlorides and sulfates of calcium and magnesium. Let us say I'm going to run the hard water through this permutate. When I run the hard water through this permutate, what is this permutate? This is Na2Z, as I told you earlier. Okay, yes, are you able to understand my point? Now when I run the hard water through the permutate, okay, what is the reaction that is happening here? CaCl2 plus Na2Z gives rise to what? CaZ. See this, okay, two molecules of NaCl will be eliminated and it is forming what? CaZ. That means when I run the hard water through the permutate, the calcium ions gets trapped in these pores. The calcium ions, okay, will get trapped in these pores to form, okay, what? Calcium silicates, isn't it? Calcium aluminium silicates, isn't it? Okay, therefore the emergent water will be free from calcium. All the calcium ions will get trapped inside these pores. When all the calcium ions gets trapped inside these pores, the emergent water will be free from what? Calcium ions and magnesium ions. Not just calcium ions, even magnesium ions will get trapped inside the pores. Okay, therefore the emergent water will be free from calcium ions and magnesium ions. Therefore it is going to be a soft water. Very simple. Okay, when I run the hard water through permutate, okay, so there is exchange of ions. Okay, that means calcium ions will get trapped inside the pores. Okay, the emergent water will be free from all the, okay, salts of calcium and magnesium. That means calcium ions and magnesium ions. Therefore it becomes what? Soft water. Soft water. So this process is called as permutate process. Now last technique, what is it? Ion exchange resin method. Okay, ion exchange resin method. Okay, the next technique is called as ion exchange resin method. Okay, so what is this resin? What do you mean by resin? Okay, resin means they are either acids or bases. They are either acids or bases with long organic molecules. Okay, or with large organic molecules. Large organic molecules. Are you getting my point? They are either acids or bases with large organic molecules. Okay, look at for acids. See, this is nothing but R, okay, COO minus H plus. Okay, it's a large organic molecule, it's not a simple molecule. Okay, so well, this base, observe the molecular formula. Okay, basic resin, it is NH2OH. R NH2OH. See, this is also called as cationic exchange resin. Cationic exchange resin. cationic exchange resin, and this is called as anionic exchange resin. Anionic exchange resin. Anionic exchange resin. Cationic exchange resin and anionic exchange resin. Now, okay, let us see how to convert hard water into soft water. Now, what I'm going to do is, I'm going to pass the hard water first through cationic exchange resin and then through anionic exchange resin. Okay, yes, when hard water is passed through cationic resin, exchange resin and then anionic exchange resin, the emergent water will be free from calcium ions and magnesium ions. Therefore, it's going to be what? Soft water. Now, what is going to happen if I first pass it through, okay, cationic exchange resin and then anionic exchange resin? Look here. Okay, yes. So now hard water, which contains what? Calcium salts, isn't it? Calcium salts. Now this is first passed through cationic exchange resin, RCOO minus H plus. Okay, look here, this RCOO minus will form salt with what? Calcium. See this R, okay, COO twice, okay, calcium, isn't it? Now the water, okay, becomes free from calcium ions. Okay, it is because calcium ion is forming, okay, salt with this RCO twice. This is nothing but insoluble salt. Insoluble salt, it can be removed by filtration. Okay, and we'll have what? H plus ion and chloride ions. Okay, yes, of course, here also we get free water which is free from calcium ions and magnesium ions, but this water is not fit for drinking. Why this water is not fit for drinking? Because it contains H plus ions and Cl minus ions. It is not fit for drinking. That is why, what is that we're going to do is, we're going to pass this water containing H plus ions and Cl minus ions through anionic exchange resin. What was that anionic exchange resin? RNH2OH, isn't it? Okay, so now first we have passed the hard water through cationic exchange resin. Okay, all the calcium ions and magnesium ions have exchanged, okay, and they form complexes. Now water is free from calcium ions and magnesium ions, but it is not fit for drinking because it contains H plus ions and Cl minus ions. Therefore, that water is passed through anionic exchange resin. Now what is going to happen? It will form RNH2Cl plus H2O. Look here. Okay, so we have removed all H plus ions and all Cl minus ions by passing through anionic exchange resin. Okay, now the emergent water, first it will be free from calcium and magnesium ions. It is also free from all the H plus ions and Cl minus ions. This water will become, it will be fit for drinking. Okay, this is how we convert, okay, a permanent hard water into soft water, through which process? Ion exchange resin method. Okay, so that's all about the hardness of water. So in the next video we will be talking about one more oxide of hydrogen, that is called as heavy water. Okay, thank you.